you'll see in a bit. So let's go to page 45 here. Or were there any questions about 40 to 44? Right? Any questions? Any questions? All right. Regressions or points are missing. So these are not, you need to come up with the missing points. And here's what I want to say to you before we start. I didn't put a spot, I didn't dedicate, but I thought of it later. For linear, you need 2 points minimum. For quadratics, how many? Anybody remember? You need at least 3 points, or else it will actually give you an error. If you try to do a quadratic without the 3rd point, it will give you an error. And for cubic, how many do you think? 4 points. And do you notice that it's degree plus 1? Degree of linear is 1, right? Plus 1 is 2. Degree of quadratic is 2, plus 1 is 3, right? So it's 1 more than the degree. That's the minimum number of points that it needs to actually perform the regression. Okay, so today we're going to focus on quadratics. You notice that linear, I'm not spending a whole lot of time because it's not as complicated, right? Okay, type 1, profit revenue questions. Don't worry so much about the type, like the number type. In grade 11, I kind of give you the 0, 1, 2, 3, right? But just think of the profit / revenue questions, right? That's what I want you to highlight. If you notice something, right? If you're charging this much, you're gonna sell less, right? If you keep increasing your rate, like Netflix, right? Any streaming service, they keep on upping it. They keep on upping it, right? Like to add more content, quote unquote, right? But they know, right? They know how much they can get away with, right? The more you're hooked, the more they can increase it. Just slowly. Don't do a crazy jump. Just be like $1 here, right? And so, but they know that if they charge too much, they're going to start losing customers. So they kind of find that sweet spot to get the most money, to make the most revenue. And that's what we're kind of going to look at here. Types 1 to 3 require you to create a table to produce at least 3 points. There it is again, to perform a regression. Keywords for this type of question is profit, revenue, items sold, and so forth. Then you will know, okay, this is definitely one of these. These are your steps here. You're gonna make a table with the 3 entries. You will have to pick, L1 will have to be one of these here. So L1, right, your X values will either be the items sold or rentals or tickets sold or whatever. But the last one is always L2. If you don't get this right, you're not going to get a quadratic regression. A is actually going to be equal to 0 if you don't do that. So always, that last column is always our L2. And you notice that profit is equal to cost times the number of items. That's a very basic concept, right? Like if you multiply these two, you get your profit. Hence, to get the cost, we would just go profit divided by items, right? If you want the items sold, you just take profit, profit divided by cost, right? Like from this, we can also deduct those two, right? If you know your profit and the number of items sold, just divide them to get how much you paid per item. And if you know the profit and the cost, then you just divide them to get the number of items sold. So that you'll see, some of you probably know where this is going. Sometimes we use this to figure out the missing piece, one of these missing pieces, because I might give you these two, you might know these two, or these two, right? If you know any two here, and notice that profit always stays, right? If you divide these two, you get that. If you divide these two, you get that, right? Enter cost or items into L1 and profit into L2. Note What goes into L1 depends on the wording of the question. Does it ask for the equation relating the cost and the profit, right? Is it cost and profit? Then this would be L1, L2. Is it items and profit that you're relating the number of items sold and the profit? You would put it that way. Okay. Restaurant owners, I was talking, these the Roberts were talking about restaurants, if you don't mind. I was chiming in, and Francis joined that. Restaurant owners know, right? They try to find that some restaurants charge a lot of money, right, for their meals. And then there are restaurants that are actually trying to target, they want to have the meals cheaper to have more customers come in, right? So that there's like the two ends of the spectrum. But they might actually profit about the same at the end of the day. They might. We don't know. We would have to look at their books, right? But if you charge a lot, then you might have fewer customers, or you might be serving fewer customers on average. If you charge less, you make up with volume, right? More customers coming in on a regular basis, you still make money, right? And so that's kind of what we're going to look at here. Perform the regression using quadratic regression. Make sure that the resulting equation does not have a equal to 0, then you're in trouble. That would be linear. Star, since L1, L2 are being used, turn on plot 1, right? You're doing, it's actually important to highlight the whole thing. Use zoom 9 to help you see the graph. Adjust your window until you see the entire parabola in quadrant 1. You need to adjust your window. Zoom 9 is just a starting point, okay? Generally, so some teachers don't even like to use the zoom functions. They're like, no, stay away from zoom. Don't do zoom. Then that's what you do, right? That's fine. But it is an option. Generally, questions of this type will ask you to ask how the profit can be maximized, right? Obviously, the idea is like, hey, how can we make the most money here? This means that you will need to find the vertex, right? That will be given by the vertex. A break-even situation happens at the x-intercepts. So break-even would be here and here. So why do I have two graphs here? Well, both of them have profit here. Okay, both of them. Profit or revenue. There's a slight difference actually in the finance world. Revenue is just how much you sold in general. Profit is how much you actually got to keep after the expenses, but we won't go into those details. So let's say the first one, you have the cost, right? Cost per item, dollar amount, and the other one is items sold. Okay, so you're comparing cost and profit here, you're comparing items sold and profit there. This is still, right, the cost and the max profit right here. Okay. And this one is items sold and the max profit. What happened there? Profit. Items max profit is found right here and here. Okay. So what else do I need to say? This is break even. I'm going to go break even. You're not making money, you're not losing money. That's just what, if the question ever says, hey, what's the break even point? How much should you charge? Obviously 0, 0. If you sell nothing, you make nothing, right? So that is not really a good feasible one. You want to look at these ones here, okay? What else do I need to say about this? I think we're good to go now. So we're going to start our first problem here. Go to 46. I may or may not provide the table, but if it's not there, you need to know how to create it, right? It doesn't have to be a fancy table like this. But here it is. A movie theater charges $1.80 per ticket. At this price, they sell approximately 400 tickets per day. The manager has observed that for every $10 increase right, is 40 fewer tickets sold. And you should see that inverse relationship. What's inverse relation? Opposite, right? Like an opposite effect. If you don't see an opposite effect, you probably won't get a quadratic, or you might get a quadratic that points up, and then you know that you're in trouble. So I will do this. Cost per ticket. This is your tickets sold. Tickets sold. And this is your profit, which is cost times tickets. So these two, ladies and gentlemen, these two do not matter if you were to flip them. Just make sure your profit is at the end, okay? Because I like to make it easier for me on marking purposes, I usually put a heading down on the test or quiz, but not always, but most of the time. So what we're told is that at $1.80 per ticket, we sell approximately 400. That means that to get our profit, we would go 180 times 400. Just leave it like that for now. Some of you already know what's happening here. It's a flashback from last year, right? And then we're told that if there's a 10 cents increase, if let's say the price is 190, so it's going up by 10 cents. 40 fewer tickets are sold, so we drop this by 40. And then our profit in that scenario would be 360. So we are creating our points in a sense. Let's increase it one more time by 10 cents. We are at $2. That would reduce the tickets sold 40 again, right, by 40. And that gives you $2 per ticket times 320 sold right there. And now you grab your calculator, but before we do anything, read the question. What does the question say? Determine the equation relating, you should know this is a quadratic, by the way, guys. If it's a profit, like it's going to be quadratic if you see that inverse relationship, right? Determine the equation relating the ticket price and the profit. So we will put the ticket price into L1 and the profit into L2. Okay, so and then we'll say stat calc quadratic. Okay, quadratic, and we're going to come up with the equation. So you take your calculator. Before you do anything else, turn on plot 1. I will clear everything in my Y's. I will go to stat edit, clear, and notice how I enter this. Ticket price, right? 1.8, 1.9, 2. The cells will be rounded, guys. The calculator will round it, but then if you hover over it, it will show you all the decimals that you enter. And then L2, watch how I enter it. I go 1.8 times 400. Like I actually just enter it there. 1.9 times 360. That's 684. And then 2 times 320, which we know is 640, right? There you go. So we typed L1 and L2. We typed these two columns. No, sorry. Yeah, I did. Cost, ticket price, and the profit are into L1 and L2 now. And you're like, what about tickets sold? Don't worry about it. It is part of your calculations to come up with this, right? Then we go stat, calculate, quadratic regression, second 1, comma, second 2, comma, vars, y vars. I bet you there's a shorter way of doing the vars, y vars. There is? What is it? Alpha trace, I knew it. Okay. See, alpha trace brings up your y's. Anyways, thank you. I'm just going to redo it. I'm just curious, did you figure it out yourself or did somebody tell you? And now I learned something. I love those days. I love learning new things. Right? It probably bothered Sai, right? It's like, it can't be this long. It has to be easier. Right? I wonder if, that's good. Um, that's my equation. Now let's graph it. I'm going to go zoom 9 right away. And zoom 9, at the very beginning, I didn't warn students and they just thought it was a linear. Like sometimes it zoom in so much that it literally looks like a straight line. And that's all they gave me on the graph, a straight line. Like it's a quadratic, right? So this is just to get you started. Then you'll go back to zoom, no, not zoom, sorry, back to window. I go slightly to the left of the y-axis. I'm going to increase to, what do you think, 20? I might have to do more. Then I go to my y min, I'm going to go negative 10 or something like that. Y max, I'm going to go higher. I have a feeling it's going to go a little bit higher. I'm going 1500. And oop, that was overkill for the x max, right? So x max should be probably 5. There we go. Even my y max is a little bit too high, but that's okay, right? You see the whole thing. And there you see your 3 dots that we were zoomed into, right? So adjust, I'm going to adjust window, right? Adjust window, make a note to you there. And so this is technically right now based on this is the cost, cost per ticket. And what is that in? Dollars, make sure you put that. And this is technically profit, also in dollars, right? And the rest is to be determined. What price would result in a maximum profit? Maximum profit. And what's the ticket price that would give you the maximum profit? And also, what is the maximum profit? Both of them will be given by the vertex. Okay. Second trace for enter, enter. And that's 1.40. 1.40. So all of a sudden the manager realizes, wait a minute, I'm being too greedy. I will actually benefit by charging less, right? Then I'll sell more. Sorry, this technically is also a dollar amount, but when you give me the coordinates, you don't need to have the units in there. And I'll just go second trace math somewhere because I used my calculator for it, right? And so a price of $1.40 per ticket will, watch this word here, yield, will result, right, a maximum profit of, in this case, $784. There you go, you answered both in one shot. Not too shabby, right? Can we just do this here? 140, 784. That's the vertex, right? It's just keep things into perspective. How many tickets are expected to be sold at this price? And this is where I told you earlier, right? Tickets, in this case, tickets sold, I will find that by going profit divided by cost, right? I told you that at the beginning. Because we actually know these two things here. We know profit and cost here from the previous question. So I'm going to go 784 divided by 140. That's exactly 560 tickets. If this had been a decimal, which quite often it is, you round it to the nearest whole number, unless you're finding the price, right? If it is a continuous data, If it is continuous data, then decimals are acceptable. All right. Next, what ticket price or prices would give yield a profit of 450? Explain why there are two possible prices. And this is going to explain what I was referring to earlier. So what I'm going to do is I'm going to make, because profit is my y variable, right? I'm going to, they're basically telling me that, hey, if that's true, what would be the possible x values? And I'm going to make that 450. If you do a profit question and it's pointing up, your parabola is pointing up, you have a prop, right? You need to go back. You need to check your math, right? Because you technically don't have a maximum profit. You have a minimum profit, right? If it's pointing up, so you can't have that. So two times that it happens, right? It happens once here. So I'm going to write down the this is 450. That's my first point. And the second time that happens is 2.31, 450. How many tickets would be sold here if we go 450 divided by 0.49, and then tickets here 450 divided by 231? Maybe that's one way of showing. We get 918.3, so approximately 918. And here we would go 450 divided by 2.31. It's about 195, right? 194.8, which is approximately 195 or 194, right? So a lower ticket price gives you 450, but also a higher ticket price gives you 450. And the reason being is that if it's cheaper, you're going to have more customers. If you charge more, you're going to have fewer customers, right? So it kind of balances off. Like that's what's happening here. So let's say you're like, well, it's COVID. You want fewer people in the building, in your theater. Maybe charging more will solve that problem, right? But let's say your mindset, your value tells you, you know what, I want to make this affordable to as many people as possible, right? But still make money. I'm going to charge 49 cents a ticket, still make the same as I would if I charge more, right? This is actually very complicated analytics, right? There's people that are very smart. They have a economics degree. They know how to figure these things out, right? The sweet spot. But here you are, right? So a lower ticket price will result in more tickets sold, right? Comma, while a higher price will see a drop in sales. Okay? Both prices result in the same profit. Are we writing paragraphs in English in math now? No. Anyways, so that's that. We're doing okay in time. We need to come up with a domain and range and graph this thing. Remember the 147.84. Try to remember that number because we're going to need it. and the x-intercept, which we're going to find in a bit, right? We need this x-intercept yet, but graph the scenario. So graph the relationship between the ticket price and the profit. Price in dollars. I'm going to do this really fast, okay? So I know it's at 0, 0. I'm going to figure out my, bless you, I'm going to figure out my x-intercept real quick. $2.80. I actually knew that. If you look, you'll see in a bit why. X-intercept is 2.80, and I used y2 is equal to 0, second trace 5. So just make a note of that. So that means that if I go 1, 2, 3, that works. 0.5, I'll make every second one. How's that? Spread it out, which means that the lines in between are 0.5, right? And my highest profit is 784, so 800 will do. 2, 4, 6, 8. There we go. 200, 400, 600, 800. 2.8 is right about. This would be 2.75. So 2.8 is just slightly to the right. This is 1.4. This is 1.5, so it would be 1.4, all the way up to 784, which is right about there. And my equation is, was it negative 400x squared plus 1120x? And there's your graph. The reason I knew this was 2.8 is because you're at 1.40, 784 up here. So if it takes you 1.4 to get to the middle, it'll take you another 1.4 to get to here, right? So you could have just doubled that vertex, the x value of the vertex to get you that. Domain and range, let's do that quick. Everything is so quick. Okay? 2.0 to 2.8, and the range would be 0 to 784. Because of course you could be making $0, right? If you either you're not selling anything or you're overcharging, wouldn't be selling anything either. So there, those are the acceptable domain and range values. I'm going to try to leave that up there, the domain and range. So try to copy that. But here, determine the equation relating the number of tickets and the profit. What if I asked you to make an equation where the number of tickets is L1 and the profit is L2? It's actually a very, very easy fix, guys. Very easy fix. I'm going to tell you to just go to Stat, Edit, and instead of putting in the ticket price, we're going to put in the tickets sold. I'm trying to remember, was it 400, 360, and 320, right? Don't touch the profit because the profit stays the same, right? You're still multiplying the same two numbers to get these. And then run it again. Run your regression one more time. I'm going to quit the first page, or my Excel spreadsheet, I call it. I'm going to rerun my quadratic regression. I'm going to copy it because I just did it, and here it is. It looks completely different, right? And that's okay. Y is equal to negative 0.0025. I do everything because it's a finite, plus 2.8x. And that's your, so stat, calc, quadreg. And you know what? I think I'm going to skip I. It's the same profit. It's the same profit. still 784. Even if you found the vertex of this, you find the vertex, it's still going to be 784. And tickets sold, where did we already calculate that? We already calculated that earlier in, what was that question? D, right? In D, we found that it was 500 and, I just looked at it and I forgot already, 560. We figured it out already because we used that other equation. We knew the cost per ticket at 784, we divided them to get 560. But if you use this, I'm just going to show you because I find it good to know. So I got to redo my window now. Did you notice that? Zoom 9. Now it's showing the other side. I'm going to go 2000 max. I need to have at least 800 for my Y max, and there it is. You go second trace 4 for the max, you're going to figure out that, see, your profit is still 784, and your tickets, watch that, 559.9999, right? That's 560. So it's just a different quadratic equation, still talking about profit, but now we're considering the tickets sold. Okay, this is it for profit. Okay, just one example. That's all I'm going to give you. And then we're going to skip to story, which is on 52. Don't worry so much about the type number, just that it's a story. It's kind of like we use the symmetry of the parabola. We're going to use the symmetry of the parabola. I'm going to call, like, when it's a story, I'm going to basically focus on find the third point using symmetry. That's what I want you to get out of today's lesson for this particular type. Use this symmetry to find the third point that you're missing. So some scenario. Watch this. If the starting point and the vertex is given, right, you will have two different scenarios to consider. You're on the ground when you kick the ball or something is, right, or you're off the ground at the starting. Okay, so let's read the story. There's a short story for all of them. A ball is kicked and reaches a maximum height of 17 feet after 1.25 seconds. A ball is kicked. So we would consider this 0, 0. Write this down. Okay, 0, 0 is the origin here. Time is the x variable. So you got to make sure you put this in the right place. It's 1.25 is my x, and 17 is the maximum height I reach. How can I find this point? I'm glad you asked. Look at where you start. This is very important because unfortunately a lot of students get this wrong. You start at 0, right? Your height is 0. So this height over here is 0. Yeah, 0 and 0. The question is your x variable, right? If it takes you, right? If it takes you 1.25 seconds to get to here, it will take you another 1.25 seconds to get to here. Does that make sense? So I will take this and I will just multiply that by 2. So that's 250 or 2.5. It's up to you what you want to do. So this is your third point. That's your third point. That's very important to us. Okay. And I want to encourage you to put it into a table like this. So time and height, you put 0, 0, 1.25, 17, 2.5, 0. And you should notice this. You should notice, hey, I started at 0, I'm back at 0. And that's That's how I got to double my x, or the x value of the vertex, right? This is the vertex right here, and this is the start. Start, vertex, third point. That's how we came up with it. Is this a blast from the past? I think a lot of you are probably like, yeah, I remember seeing this, right? Okay. How about an object is thrown from a height of 8 meters? Oh, okay. So that tells me I'm not on the ground. I'm off the ground right there. And reaches a maximum height of 13 meters at a distance of 3.5 meters. You're like, wait a minute, which one goes where? Well, distance is usually horizontal, right? Height is vertical. So, and this is also giving it away. So you need to make sure you get this right. 3.5 meters horizontally, that's when you reach a maximum height of 13. So that's your vertex. And here is the number one mistake. You're ready for it? Don't copy this. 7, 0. Ka-ching, right? I got this. It's like, What's the problem there? Are you lined up with where you started? You're not using symmetry. This is only possible if you were to know the starting point here. But you need to focus on this. You need to focus on this point right here. So you always have like a mini parabola, right? In this case, you use the full thing. But this would be wrong, right? Wrong and error. Okay. I don't know if you want to do that, but really what you're finding is this. And notice that you started at a height of 8. Therefore, here you're going to be back at 8 at that point. That's what using symmetry is, right? You're basically focusing on the 2 points that would be directly across from each other. Then you take that and you just multiply that by 2. So it's 7, 8. This is your third point right there, not this. Okay? Error, wrong, don't do this. Never, ever. Remember. Okay, so this would be distance and height. And so you got 0, 8. This is where you see whether or not you made a mistake. Okay. Obviously, this is going to go into L1 and L2, right? That's what I'm after here. And so this is your start. This is your vertex. And this is your third point. You know where I'm going with this, right? If you have the vertex and your starting point, just go right across and try to find the one that's right across from it. That's what I'm trying to say here. This is better than jumping right in because now you know what's happening, right? You can tell. I'm going to read carefully and figure it out. Now, start and end point given, no vertex provided. So this is where you have no vertex. You're going to have to figure out the vertex. So the top ones, you had the start and the vertex. You found the third. And this is where it's basically I'm giving you the start and the third. You need to find the vertex, which is still the third point, right, that you're missing. So here, same scenario. You're on the ground. You're off the ground. And notice that I have one that actually goes up, which it is going to happen from time to time. Here, an object is thrown upwards, reaches a maximum height of 40 feet, and lands and remains airborne for 8 seconds. Let's just get rid of this. And lands. Yeah, it's just maximum height of 40 feet and remains airborne for 8 seconds. That's what I want you to keep there. It's really small, I apologize for that. But the graph kind of tells you that this is 0, 0, that's what I need. I'm told that I remain airborne, or this projectile, the object, remain airborne for 8 seconds, which is telling you that it's the x-intercept. It's how long it took for it to actually hit the ground. We need partial information for the vertex, and we actually do. It tells us that we reach a maximum height of 40 here, right? I'm going to use a red pen to write in the x value here. So again, you use symmetry, right? This distance is the same thing as this distance, right? So you would just have to take the whole distance and split it in half to get the middle. So you do the opposite. Right? From vertex to the third point, you would multiply by 2. In this case, you would just divide by 2. So you get the 440 there. And so you get time and height. This would be 0, 0. By the way, the order in which you enter these points doesn't matter as long as you keep them together. Okay? 440 and an 80. And again, you should notice this. Then you know for sure you're doing it right. The only exception, this is not necessarily a rule if the question actually gives you 3 points. If it gives away 3 points, don't worry about this pattern. But when you're making it, when you're creating the third point, you need that pattern. Capiche? Right? ¿Entienden? That's Spanish, or do you get it? A skier goes down a 30-foot ramp. Okay, so this is my ramp here. It's 30 foot off the ground. So I'm going to go 0, 30 right there. Notice that I'm comparing distance and height. So the lowest height is 12 feet and reaches the initial height at a distance of 50 feet. What's going on there? Reaches the initial height. They're basically telling you if you were to take that initial height of 30 and trace it across this parabola, you should be able to find that point right there. We are actually told that it takes a distance of 50 feet to get back to the 30 that I initially started at, right? That's what this question is saying. And we have partial information on this. We know that the lowest height it reaches is 12. So if it takes 50 feet to go from here to there, it stands to reason that it would take half the time to get to the middle of this thing. Again, we're using symmetry, right? This distance is the same as that. So I will just go all around like this, divide it by 2, and get my 25. I used round numbers to make it easier. It won't always be. Distance, height, 0, 30, 25, 12, and 50, 30, which tells you that you're doing something right. Again, start, vertex, third point. In this case, you found a vertex, right? Start, vertex, third point. Okay, enough of this. Now let's actually do a question or two. I'm tired, never mind you guys having to listen to this. You good? I'm going to select. Yeah. Let's go to 53 here. Read it, make a little diagram and see if you can, somewhere here guys, a nice small sketch of this scenario. Could you come up with 3 points before it gets started? Because you know you're smarter than you think, remember? That's Scotiabank's motto, right? You're richer than you think. Same thing with being smart. You don't even need me. You won't hurt my feelings. That's okay. All right. Maybe take some skills to interpret the question sometimes, right? Roger would like to recycle beverage. Throws his container up from a height of 1.75, so I know it's not on the ground, right? So 0, 1.75. estimates that it will reach a height of 2.8 after 0.75 seconds. So I know somewhere up here is my vertex. So I'm giving the initial and the vertex. So there's going to be a times 2 thing, not a divide by half, remember? The container lands on the rim of the recycling bin, and the bin is 0.65 meters tall. So there's the recycling bin somewhere down here, right? It's lower. And I'm actually kind of guilty for, I'm trying to trick you here. I don't know if you noticed that. This is 0.6, no, sorry. I don't know the time it takes, right? I don't know the time, but I know that this is 0.65. The rim of the, you know those recycling bins, right? That you see that just have a small hole, but there's a big rim around it, right? And missed it, right? And I'm trying to trick you here to use that one. But you should remember that we're using symmetry. It's this one really that you want. This is the one you know, right? You reach that height of 1.75 again after multiply that by 2, right? 1.5. So yes, I'm guilty of, if you chose this one, sorry about that, but not so sorry, right? So it's this one. This is just there. Maybe it's coming back later. Maybe it is. Maybe domain and range is going to be affected by that, right? We know it stops here, but that's beside the point. This is what you want to use, right? You want to use the symmetry of the parabola, and so that's 1.5, 1.5, 1.75. So I will go time and height and just put those points down. 0, 1.75, 0.75, 2.8, and then 1.5, 1.75, right? Remember? Right? Remember that? So you tell me L1, L2, and then this should tell you that this is a quadratic regression. Stories like this, motion of objects thrown in the air, anything like that should tell you it's a quadratic. And it also tells you that it's a quadratic right here. So it's kind of like lots of hints here. So type that in. 0, 1.75, 1.5. Make sure you enter it right. I'm making a mistake right there. You see it? Let me redo it. There's no multiplying or anything like that, just like the profit question, right? There we go, stat calc. What is it? Alpha trace? Yeah, there it is. Negative 1.87 x squared plus 2.8x plus 1.75, which makes sense, right? It should start, the initial height should be 1.75. We're good. How long does it take for the beverage container to reach the rim of the recycling can? So let's say you missed it up here. If I give you a whole question to ask what it is, and it's as easy as just copying the 1.5, then you know it's probably not it, right? So recycling can, right, is at a height. So y2 is going to be 0.65 for me, and I'm going to figure out when is it going to land there. So I'm making y2 0.65. I'm going to graph. Whoa, I didn't adjust my window yet. So I'm going to try zoom 6. Actually does a pretty good job. But you got to be careful because it could have hit it on its way up. And you know, right, like it needs to be when it lands, when it's on its way down. So just make sure you understand that. So it's, in this case, it's just the only option is that, because the other one would be negative, right? So I'm going to go over and find that intersection, which is 1.82 second trace intersect, and that is 1.82, 0.65, right? It takes 1.82 seconds. That's it. That's all I need. I don't know if you want to. You love highlighting, right? You don't mind it. But I'm just going to say this point is really this point right here, right, that you're trying to find. And see, this is the good news for you. Let's say you completely get this wrong. Oops, sorry. Let's say you get this wrong. If you are consistent on everything that follows, you still earn marks there, as long as it's consistent, right? As long as it jives with what you gave me up in A, as long as you do the correct steps, unless the step requires zero work. If all you need to do is copy something down here, then you wouldn't get the marks. Okay, you still have to do a significant amount of work. So it doesn't matter if you make a mistake as long as you do the work. Next, how long does it remain below 2.5 meters? So we need to go y2 is equal to 2.5 and figure out if this is goes like this. We're probably going to have a line that goes like that. That's our 2.5 meter line. And we're going to find out those x values. Let me adjust my window a little bit. I feel like it's too much. I don't need that much. There you go. That's better. So second, watch. I'm going to just make a reference here. It doesn't cut into it anywhere else other than here. So our initial time is not back here, guys. It's 0, right? That's our initial time when the action starts. So it's just from 0 to here. Okay? So those are the two numbers that we technically subtract, but you wouldn't be subtracting by 0. It doesn't make a difference, right? Sorry. Second trace 5. Let's try it again. And it's 1 point. Sorry. I'm probably off, right? I take everything back I just said. And now let's do it again. These are the two times it actually does cut through the parabola twice within our domain and range. What is he talking about, domain and range? We haven't answered that yet. Well, it's positive time for sure. So that's 0.3491, 4 decimals, because you know you're going to have to subtract them. And this one right here, I should have that handy, right? 1.1509. 1.1509 rounded to 4 decimals. So I would give you, at this point, you would already have 1 mark for finding these two, and then you get another mark for actually subtracting them. That's how the province marks this. Yeah. You would not lose any marks. I just need to see those points. And I think I'm not done yet. I'm not done this question, because when I do this, when I subtract these two, what am I finding really? The time that elapsed, right, when this thing was above, right? So this is actually, I will make a note of that when I do the calculation. And I always make it, when I do my examples, obviously it goes through a lot more seconds. Sorry. This would be time above. Don't worry so much about the at or above or something like that. Just, it's so minimal, like we would have to really cut and slice to get that micro millisecond or whatever. So don't worry about that. But this is time above. Let me maybe, right? This time is what happened while it was up, right? You want to know how much time is below. So time below you would take the total time that elapsed from when it was thrown until it hit the rim. Where is that answer? It's actually right up here. So we're going to take the total time this thing was in the air and subtract 0.8018. And I can use the 1.82 because I'm using it from a previous answer, and then it's fine to have it rounded. And so that is 1.02 seconds. This is the final answer right here. So, okay, I want to make sure that you understand. If this question said remains at or above 2.5 meters, you would have been done here. That would have been it. But because it asks for below, we figure out that part right there. And I'm going to use orange for that. So you're basically finding out this. And I'm assuming this is where this is 1.82 0.65, right? That point right there. You don't have to have a diagram. You can just give me the coordinates that you found, just subtract them, and obviously this would be one extra step, right? Having to figure out the time below instead of the time above. But both of them together add up to the total travel time, right? I will graph this and domain and range and then homework. And so my domain is the time, right? Range would be, does it hit the ground? So there better not be a 0. There better not be an infinity, right? We like our infinities, right? But shouldn't be one. So the lowest point I ever reach is the rim of the bin. And then the highest point you ever reach is given by the vertex, which is 2.8, right? It's always lowest first, highest second, always. Okay? And let's complete our graph here. Time in seconds, height in meters. And I'm going to go 1, 2 like this. I'm going to spread it. And the height is 2.8, right? So 1, 2, 3. 1, 2, 3. Yeah, that works pretty good. 1, 2, 3, like that. I'm at 1.75. That's right there. My vertex is 0.75, 2.8, somewhere there. And I'm 1.82, which is right about there. 0.65. This would be 0.5, 0.75, 0.65 is right in there somewhere. And so you go up and hit the rim. That is it. Y is equal to negative 1.87 x squared, 0.8x plus 1.75. Am I missing something? I think we're good. Homework. It's in this book. Some of you are still copying. Let me freeze that. Freeze. It's a little bit selective. It's a little bit selective. So I'm going to ask you to do I have to cut it a little bit. So watch. I'm going to post it on Google Classroom, okay, the homework, because I have certain pages that I don't want you to do. So I don't want to just give you the page range, okay? So just wait for it. Have a good one, guys. This is the homework right there. I'll post the keys later.